The Boötes Void, often hauntingly referred to as the Great Nothing, is one of the most extraordinary and unsettling discoveries in modern cosmology, a colossal region of space located approximately 700 million light-years away from Earth and spanning an immense 330 million light-years in diameter, so vast that even light, the fastest thing in the universe, would take hundreds of millions of years to cross it. Yet despite its imaginable size, this region is almost entirely empty, containing only a few dozen galaxies where scientists expected to find thousands, making it one of the largest and most extreme examples of a cosmic void ever observed. Its discovery in 1981 by Robert Kirshner and his colleagues completely reshaped our understanding of the large-scale structure of the universe, revealing that instead of being evenly filled with galaxies, the cosmos is arranged like a gigantic three-dimensional web, often called the cosmic web, in which galaxies cluster along filaments and nodes, while vast bubble-like voids occupy the spaces in between. And among these voids, the Boötes Void stands out as an almost unnatural absence of matter, a place where the normal rules of galaxy formation appear to have failed or never taken hold in the first place. To truly grasp how strange this is, one must imagine a region so large that it could contain entire superclusters of galaxies, yet instead holds only a sparse scattering of isolated systems separated by distances so great that any form of interaction between them is exceedingly rare, creating an environment of cosmic loneliness unlike almost anywhere else in the observable universe. And if an observer was somehow placed inside one of these rare galaxies, their view of the cosmos would be profoundly limited, with little to no visible evidence of the countless other galaxies that populate the universe beyond the void, potentially leading them to believe that their galaxy was alone in an otherwise empty and infinite darkness, a thought that highlights how dependent our understanding of reality is on our position within the cosmic structure. Scientists have long struggled to explain how such an enormous and underdense region could form, and several theories attempt to account for its existence, one of which suggests that the Boötes Void originated as a tiny fluctuation in the density of matter in the early universe shortly after the Big Bang, when quantum variations were stretched across cosmic scales during a period known as inflation, leading to some regions having slightly less matter than others, and over billions of years, gravity amplified these differences by pulling matter toward denser regions and away from less dense ones, effectively draining the Boötes region of the material needed to form galaxies and leaving behind a vast emptiness. Another theory proposes that the void was not always this large, but instead formed through the gradual merging of multiple smaller voids, much like soap bubbles combining to form a larger bubble, resulting in a supervoid of extraordinary size, while yet another explanation points to the role of dark matter, the invisible substance that makes up most of the universe's mass and provides the gravitational scaffolding for galaxy formation, suggesting that the Boötes Void may contain an unusually low concentration of dark matter, preventing gas from collapsing into stars and galaxies, and thereby leaving the region largely barren. Although none of these theories fully account for the extreme emptiness observed, which continues to make the Boötes Void an active area of research and debate among cosmologists.
Despite its nickname, the void is not completely devoid of matter, as a handful of galaxies do exist within it, but these galaxies are remarkably isolated, often separated by tens of millions of light-years, and they provide valuable clues about how galaxy formation can occur even in the most inhospitable environments, offering scientists a unique opportunity to study how galaxies evolve when they are almost entirely cut off from external influences such as gravitational interactions or mergers with neighboring systems, which are common in denser regions of the universe. Beyond its scientific importance, the Boötes Void also carries profound philosophical implications as it challenges our intuitive understanding of the universe as a place filled with stars, light, and structure, instead revealing that vast regions of near-total emptiness are not only possible but are fundamental components of the cosmic landscape. And its existence forces us to confront the idea that nothingness itself can have structure, scale, and significance, shaping the distribution of matter and influencing the evolution of the universe in ways that are only beginning to be understood. Furthermore, the void is not static but continues to evolve over time as matter is gradually pulled towards surrounding filaments and clusters under the influence of gravity, causing the void to expand and become even emptier, a process that mirrors the larger-scale expansion of the universe driven by dark energy. And some scientists speculate that in the distant future, as cosmic expansion accelerates, galaxies will drift farther and farther apart until vast regions of the universe begin to resemble the Boötes Void, with isolated galaxies surrounded by immense stretches of darkness, effectively turning much of the cosmos into a series of enormous voids, making the Boötes Void not just a curiosity of the present universe, but potentially a glimpse into its long-term fate. In this way, the Boötes Void serves as both a window into the past and a preview of the future, preserving clues about the initial conditions of the universe shortly after the Big Bang, while also hinting at how cosmic structures may evolve over trillions of years. And by studying this immense and enigmatic region, scientists hope to refine their models of cosmology, test the limits of our understanding of dark matter and dark energy, and perhaps uncover new physics that could explain why such an extreme void exists at all. Yet even with all our current knowledge, the Boötes Void remains a deeply mysterious and almost poetic feature of the cosmos, a silent, dark expanse that stands in stark contrast to the brilliance of galaxies and stars, reminding us that the universe is not only defined by what it contains, but also by what it lacks, and that within this immense emptiness lies a powerful and humbling truth about the nature of reality itself, that even in a universe filled with billions of galaxies, there are places where almost nothing exists, and yet those places may hold some of the most important answers of all.